Hey everyone, and welcome to Science Manthan. Today, we're diving into a brand new explainer, and we're going on a journey into the fundamental building blocks of, well, literally everything around us. Have you ever actually stopped to look closely at the materials making up your everyday life? You know, the water you drink, the chair you're sitting on right now, the air you're breathing. They all have these incredibly specific, totally predictable properties. So today, we're going to unpack these core concepts: solubility, mass, volume, and matter. We'll take it step by step and see exactly how they shape our world. To kick things off, I want you to picture something you've probably done 1,000 times. You've got a glass of water, and you mix a spoonful of, say, sugar or salt into it. Why do some things seemingly just vanish right before our eyes, while others, well, they just sink to the bottom and sit there, completely unchanged? It looks a little bit like magic, but actually, it's one of the most revealing physical properties in all of science. When we mix substances with water, their behavior tells us a massive amount about what they really are.
And that brings us straight to the concept of solubility. On one hand, we've got soluble materials. You mix these with water, and they dissolve completely to form a nice, uniform solution. Sure, the water might change color or taste, but the solid material has essentially become one with the liquid. But on the other hand, we have insoluble materials. These guys stubbornly refuse to mix at a molecular level. No matter how hard you stir, they're going to remain entirely unchanged.
Now, you might be sitting there thinking, okay, neat chemistry trick, but does this really matter outside the lab? Absolutely. The truth is, solubility is the invisible engine running our modern world. In cooking, it's exactly how we extract flavors for our soups and teas. In medicine, it dictates how a pill dissolves in your stomach so it can deliver life-saving relief straight into your bloodstream. Even in agriculture, fertilizers have to dissolve into the soil to be absorbed by roots. And in massive industrial processes, it dictates how we manufacture everything from cleaning supplies to advanced chemicals. So yeah, it's a simple mixing property, but it is an absolute necessity for our survival and progress. But hey, here is where a lot of people actually get tripped up. When we think of something dissolving, we usually picture a solid powder mixing into a liquid, right? Well, solubility isn't just for solids. Liquids and gases have their own incredibly dynamic, fascinating relationships with water too, and they mix and interact in ways that are just as vital to the world around us. Let's take a look at liquids first. Just like those solid powders, different liquid materials behave completely differently when you put them in water. Some liquids mix perfectly, blending into a single, seamless, uniform fluid. But others, they simply refuse. Instead of blending, they repel the water and actually form entirely separate layers, literally stacking right on top of one another based on their unique properties. And then there are gases. Check out this fascinating insight from our source material. Certain gases, especially oxygen, dissolve in water and support the survival of aquatic organisms. I really want you to think about that for a second. We just talked about solids and liquids, but gases dissolve too? Without the incredible property of oxygen seamlessly dissolving into liquid water, aquatic life just wouldn't exist. Fish and entire underwater ecosystems rely completely on this invisible dissolved gas to breathe and survive beneath the surface. It's literally an invisible lifeline, and it's made possible entirely by solubility. So, okay, we've established how different materials mix. But in science, just looking at something isn't quite enough. We need to quantify it, right? How do we put strict, universally understood numbers to the physical reality around us? Well, that brings us to the next major step in this explainer, understanding exactly how we measure all these materials. First up is mass. Simply put, mass represents the amount of matter present in an object. Whenever you're comparing heavy and light objects, you're fundamentally determining which one contains more stuff. And to make sure everyone around the globe is on the exact same page, we measure mass using standardized units, typically grams for smaller amounts, and the official SI unit, kilograms, for the big stuff. But mass is really only half the story here. The other crucial measurement is volume. Volume is just the amount of space a substance occupies. Picture the containers in your kitchen right now. You know, a tiny teacup versus a massive water jug. Those containers perfectly illustrate differences in volume, or capacity. Whether we measure it in everyday liters and milliliters, or the strict scientific cubic meter, volume isn't about how heavy something is. It's purely about how much three-dimensional space it's stealing from the universe. You know, it's actually surprisingly easy to get these two mixed up, so let's put them head to head for a second. Mass is the amount of stuff. Volume is the space it takes up. Think of a massive party balloon. It takes up a ton of space, so huge volume, but it contains hardly any actual matter, which means it has very low mass. Now flip that. A tiny lead weight takes up almost no space at all, but it packs a tremendous amount of matter into that tiny footprint, giving it a very high mass. Grasping this distinction, it's an absolute superpower in physics and chemistry.
All right, so we've talked about how things mix, the amount of stuff inside them, and the space they take up. Now it's time to pull the camera back for a real aha moment. It is time to unite all of these separate measurements under one incredible foundational concept: volume.
And here it is, matter. The definition is so simple, but unbelievably profound. Anything that has mass and occupies space is called matter. This is our grand unifier. The water, the solids, the dissolving gases we talked about, the heavy lead weights, the light balloons, every single thing we have discussed today that has mass and volume is an example of matter. So if literally everything is matter, where does the word materials come in? Well, materials are just specific forms of matter. We select these specific forms to make useful objects because of their unique properties, like you guessed it, their solubility, mass, or volume. A blob of iron and a pool of water are both matter, but we choose them as materials for entirely different jobs based exactly on how they behave.
Which leads us to a very fair question. Why does studying these properties actually matter in the grand scheme of things? Why do we go to all the trouble of memorizing solubility, calculating mass, or measuring volume? I promise it's not just to pass the science test. It's because understanding these properties is the absolute foundation of the designed world around us.
Understanding how matter behaves helps us choose the exact right materials for highly specific purposes. In engineering, experts completely rely on knowing mass and volume to design bridges and structures that are both safe and efficient. Over in manufacturing, understanding solubility and material behavior is exactly how we create durable, reliable products that won't just fall apart. And in pure science, grouping materials based on these physical traits simplifies how we make new, groundbreaking discoveries faster. Basically, our modern safe world is built entirely on experts understanding these exact principles.
So, to wrap this all up, the physical properties of solubility, mass, and volume determine how everything behaves and exactly where materials are used. The building blocks are all around you, just waiting to be understood and utilized. Which leaves me with one final question for you. What will you build with your matter? Thank you so much for joining me on this explainer journey. Please like, subscribe, and share for such more science-related videos. Also, drop your comments and queries in the comments section. We will catch you in next one.